In this video, we will review some matrix vocabulary and do some basic matrix operations. When we talk about the dimensions of a matrix, we are talking about the number of rows and the number of columns. Rows go across and columns go down. So for matrix B, this has 2 rows and 3 columns. So this is a 2 by 3 matrix, and those are the dimensions. When we ask what is the entry in location B sub 2, 1, let me make this a little bit bigger. We have B, and then we have 2, 1. The 2 is the row, and the 1 is the column. All right, it's always row and then column. So row 2, column 1 of matrix B. The fact that we're using a lowercase b means matrix B. So row 2, column 1, okay, that is this entry right here. So that is going to be -1. For part C, we are to identify the dimensions of the product of DB. So let's see, we're doing matrix D times matrix B. So the dimensions of matrix D are 3 by 2 because it has 3 rows and 2 columns. Now matrix B has dimensions 2 by 3 because it has 2 rows and 3 columns. In order to multiply, the inner dimensions must be the same. So this is good because that means this product is defined. And we know that the dimensions of the product will be the outer dimensions. Okay, so the dimensions of the product D times B will be 3 by 3 because those are the outer dimensions. So what's the entry located in D3, 2? That's matrix D, row 3, column 2. So this is row 3, and this is column 2. So as you can see, we are talking about entry that is 9. For part E, we are to perform the calculation 2A minus 3B. So that's 2 times matrix A minus 3 times matrix B. So of course we will just take matrix A and multiply everything by 2, and we will take matrix B and multiply everything by 3. So that gives me this so far. Finally, we need to go ahead and subtract the first matrix minus the second matrix. So for the final answer, we will just subtract each entry in the first matrix minus the corresponding entry in the second matrix. So this will be the final answer. Take special care when you're subtracting a negative number. Remember that this is 0 minus -3. When you subtract a negative, you're actually adding. So this is really 0 plus 3, and that's why I'm getting a positive 3. For part F, we are to add A plus D, but this is going to be not possible because the dimensions have to be the same. This is a 2 by 3 matrix, while this is a 3 by 2 matrix. The dimensions are not the same, so it can't be done. For part G, we need to multiply matrix A times matrix D. First, let's analyze the dimensions and make sure that this is possible and figure out what will be the dimensions of the final answer. So matrix A has dimensions 2 by 3, 2 rows, 3 columns. So matrix A has dimensions 2 by 3. Matrix D has dimensions 3 by 2, 3 rows, 2 columns. The inner dimensions are the same. So this will be possible. The inner dimensions have to be the same. The outer dimensions tell you the dimensions of your final answer. So we know that our final answer will be a 2 by 2 matrix. That's going to be important to us right now because we need to set up a giant 2 by 2 matrix. Okay, so here is a giant 2 by 2 matrix which we will use to show our work. So what we're going to do is we're going to take all the rows from the first matrix, and then we will take all of the columns from the second matrix. Okay, so first of all, we have the first row, 3, 6, -1. Row 1 belongs in row 1 of the answer. Okay, so this is row 1, and it is 3, 6, -1. Now I'm writing it vertically even though it's a row, just to make the calculations easier to perform. Okay, but this is row 1. And we will also put row 1 right here, 3, 6, -1. So we put row 1 throughout row 1 of the answer. Okay, let's go ahead and do row 2 while we're at it. This is row 2. We will put row 2 throughout row 2 of the final answer. So row 2 is 0, 5, 2. So 0, 5, 2. All right, now let's do the columns, which come from the second matrix. This is column 1. Column 1 will go throughout column 1 of the answer. So that's why I'm going to have 1, and this is a multiplication sign. So this is times 1 times -2 times 0. 1, -2, 0. Column 1 goes throughout column 1. And now let's do column 2. Column 2 goes throughout column 2. So here we will have 3 and 5 and 9. All this is multiplication. And again, 3 and 5 and 9. So now I will do the multiplication that I just indicated. So I'm going to get 3 and -12 and 0. And then I just add those up for the answer. So -12 plus 3 is -9, plus 0 is still -9. So this is the entry, row 1, column 1. So I'll do the same thing for all of the other entries. I will multiply and add them up. So this is going to be 9 and 30 and -9. The 9's cancel, so I'm just going to have 30. This will be the entry in row 1, column 2. Multiply here, I get 0, -10, and 0. I want to add them up. That's -10. That'll be the entry in row 2, column 1. And I get 0 and 25 and 18. And that is 43. So the final answer is going to be the 2 by 2 matrix, -9, 30, -10, and 43. For part H, we need to do A transpose times B. But what is A transpose? When you do the transpose of a matrix, all the rows become columns, and all the columns become rows. So row 1 is 3, 6, negative 1. That means column 1 is going to be 3, 6, negative 1. Row 2 is 0, 5, 2. In the transpose, that will be column 2, 0, 5, 2. Notice that this affects the columns automatically. Column 2 was 6, 5. Now row 2 is 6, 5, for example. So this is a transpose. So this is a transpose, and this is matrix B. So we need to multiply these two together. First of all, let's do our dimension analysis and make sure that this is going to work out. So the dimensions of A transpose are 3 by 2, because 3 rows, 2 columns. The dimensions of matrix B are 2 by 3. That's 2 rows, 3 columns. This is going to be possible because the inner dimensions are the same, and the dimensions of our product, our final answer, will be a 3 by 3 matrix. We can tell because of the outer dimensions here. So since the dimensions will be 3 by 3, that tells us that we need to set up a giant 3 by 3 matrix. So that's what I'm going to do right now. I'm going to set up a great big 3 by 3 matrix. Okay, so here is my giant 3 by 3 matrix setup. Now when I do my multiplication process, I will use the rows of the first matrix and the columns of the second matrix. So let's start with the rows. So row 1 is 3, 0. So I'm going to put row 1 throughout row 1 of my answer. So I'm going to put 3, 0, 3, 0, 3, 0. Don't worry about the fact that I made this vertical, even though it's a row. It just makes my calculations easier. So now I've got row 2, 6, and 5. So row 2 goes throughout row 2 of my answer. So what did I say, 6 and 5? So I'm going to have 6 and 5, 6 and 5, 6 and 5. Row 2 goes throughout row 2. Okay, and finally row 3, negative 1, 2. Row 3 goes across row 3. So I will have negative 1, 2, negative 1, 2, negative 1, 2. Row 3 goes across row 3. So that's it for the rows. Now it's time for the columns. All right, column 1. 1, negative 1. Column 1 goes down column 1. So I will have times 1 times negative 1. All the way down column 1. Times 1 times negative 1. Times 1 times negative 1. Okay, next we have column 2. Column 2 goes down column 2. So I will have times 0 times 2. Times 0 times 2. Times 0 times 2. Okay, and finally column 3, 5, 7. Column 3 goes down column 3. So times 5 times 7 times 5 times 7 times 5 times 7. All right, so now I'm just going to do all of the multiplication that I just suggested. So 3 times 1 is 3. 0 times negative 1 is 0. I'm going to add these up, and that makes 3. So that'll be my first entry, row 1, column 1. Okay, I think I'll just go straight across. So 3 times 0 is 0. 0 times 2 is 0. Add them up, that makes 0. I'm going to have 15 and 7. Okay, add them up, that's 22. All right, here I'm going to have 6 and -5. Add them up, that's 1. 0 and 10. Add them up, that's 10. 30 and 35. Add them up, that is 65. -1, -2. Add them up, -3. 0 and 4. Add them up, that's 4. -5 and 14. Add them up, and you get 9. All right, so my final answer should be 3, 0, 22, 1, 10, 65, -3, 4, 9. Actually, sorry, I made a little mistake here on this position. All right, I'm sure you noticed it, and you were screaming at me to catch it. 0 times 7 is 0. So this is not 22. This is 15. So that is your final answer. All right, for part I, we have to do C squared. That means matrix C times matrix C, which is what I've copied down right now. Now, matrix C is a 3 by 3 matrix. Because the inner dimensions are the same, this is going to be possible. The outer dimensions tell us the dimensions of the final answer, which will be a 3 by 3 matrix. So we know we're going to have a 3 by 3 matrix. So I'm going to form a giant 3 by 3 matrix for myself. Okay, I think I'll change colors though. So here comes my giant 3 by 3 matrix. Okay, this is where I will do all my work. Now, all of the rows are going to come from the first matrix, while all of the columns will come from the second matrix. Let's start with the rows. The first row is this one, 2, 3, -2. Row 1 will go across row 1. So I'm going to have 2, 3, -2. 2, 3, -2. 2, 3, -2. Row 1 goes across row 1. I'm making it vertical, even though it's a row, to make my calculations go easier. Row 2, 1, 4, 5. Row 2 goes across row 2. So I'm going to put 1, 4, 5. 1, 4, 5. 1, 4, 5, all across row 2. Row 3, 0, 1, 7. Row 3 goes across row 3. So 0, 1, 7, 0, 1, 7, 0, 1, 7. Now it's time for the columns. Okay, this is column 1, 2, 1, 0. Column 1 will go down column 1. So I will have times 2 times 1 times 0 repeatedly. All right, column 2 will go down column 2. And that leaves column 3. Column 3 will go down column 3. Okay, so now I will go back and do the multiplication that I have indicated. So this is going to be 4 and 3 and 0. Add them up, and that's 7. This will be 6 and 12 and negative 2. Okay, so that's going to be 10, 16. This will be negative 4 and 15 and negative 14. So this is going to be, that's negative 3. And then I just went ahead and did the rest of the calculations in the same way. So looking at these sums, you can see what the final answer is going to look like, which I will write over here. So the final answer should be 7, 16, negative 3, 6, 24, 53, and 1, 11, 54. This, my friends, is the final answer. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.